Hi class, here we are talking about chapter 5, quadratic functions. So we've gone back to chapter 5. We're going to focus on quadratics and we're going to start focusing on the graphs of different functions. So the characteristics of a parabola. So when we look at the parabola below, what characteristics can be identified here? So some things that I want you to note is we have the axis of symmetry. Axis of symmetry, sometimes you'll see that noted as AOS for the axis of symmetry. That is the line where if we took that parabola and folded it along this dotted line in half, it would get the exact same thing. We've talked about symmetry already, so that would be the axis of symmetry. Here we can see our x-intercepts. Remember, our x-intercepts is where we are intersecting that x-axis. And then lastly, we have a y-intercept on this case. And one new terminology here is the vertex, right? So the vertex is going to be the center of the parabola, basically where we go from like shifting downward to all of a sudden now we're increasing, right? Where that vertex happens. This is going to be either the smallest possible value or the highest possible value. So if you think back to our extrema that we've already talked about, it's going to be our min or a max, and that's the vertex. So in this particular case, notice that our vertex is located at 1, -4. Our axis of symmetry is always going to be given to us in the form of an equation. So that's really important to note. It's always going to be an equation. And usually it's, that's where that line is what it's folded against, and we see that that symmetry. So in this case, it is going to be x equals 1 because that's right on where x equals 1 here. Okay. All right. Some things to note, right, when we are looking at parabolas, we're going to have two different types of parabolas. We're going to have the happy parabolas, which are going to be our positive parabolas. And then we're also going to have our sad face parabolas, which are going to be our negative parabolas, right? And so that's that A that's in the front of it. And so we'll be taking a look at that. Let's look at a couple of examples here. So here, this is going based off of the graphs alone, and I know we've seen graphs already. We've seen them in Desmos and things like that, but we're focusing some more just on parabolas here. So we want to identify the x and y intercepts. We want to identify the vertex and the axis of symmetry. So remember, we can abbreviate this as AOS. So let's take a look at a couple of these things. So x and y, when I'm looking at this first one, let's call this number 1. When I'm looking at this first one, I can see that I intersect here, and I'm intercepting over here. So let's write that down. So then that means that my x-intercept, we're going to write this as coordinate points, so make sure you're always writing this as points. That's going to be -5, 0, and 3, 0. Then we have our y-intercept. Our y-intercept is going to be located at 0, 7. Okay. So now let's take a look at that vertex. That vertex is the highest point here, and we're looking at right there. That looks like our vertex, right? And if I were to guess, right, that looks like it's about halfway through 7.5. So we're looking at when the vertex is going to be when x equals -1 and 7.5. The vertex also is going to tell me kind of where that axis of symmetry is at. So that axis of symmetry is always going to be on the x, or I guess it depends, but for the most part, it's always going to be on this value of our vertex, that x value. So it's going to be x is equal to -1. It's going to be our axis of symmetry. Okay. All right, take a moment, pause this video, and try number 2 real quick. All right, class, is this what you got? So x-intercepts, none, because we're not intersecting that x-axis. The y-intercept, I got 0, 7. Vertex is at 2, 3. And again, notice that that axis of symmetry matches that x value of that vertex. All right, let's take a look at some information here. So the standard form of a quadratic function is going to be given to us by this formula here, f of x equals a x minus h quantity squared plus k. We've seen this already when we were dealing with transformation of functions. So one thing that we need to know is that h comma k is our vertex. This is how we're defining the vertex. Because the vertex appears in standard form of the quadratic function, this form is also known as vertex form for the quadratic function. Okay, and again, because I can just look at the formula here and say, well, my vertex is going to be h comma k. The axis of symmetry is given by the equation x equals h. If A is positive, the parabola opens upward, right? So we're looking at something that looks like this. If A is negative, we're looking at a downward parabola, something negative. Okay. All right, so let's take a look at some of these examples. So for example, the following functions determine which way the parabola opens. Find the vertex and find the axis of symmetry. All right, so let's take a look at A together, and then I'll pause and have you do B and C together on your own, sorry. So here, notice that A is equal to 2, which means that because it's positive that I have a happy face on my hand. So this is going to open upward. Okay, so now when we look at our vertex, you'll notice that sometimes we'll do V of x like this for vertex notation. It's going to be, so since I have a plus 6 there, it's going to be a negative 6, and then I have a negative 5. So there's my vertex. And then my axis of symmetry is going to be x is equal to that negative 6 value. Okay. All right, try B real quick. All right, for B, is this what you got? Downward parabola with a vertex of 2 comma negative 4, and an axis of symmetry is x equals 2. If you did, excellent. Now try number or letter C. All right, here we go. So for C, we have an upward. So even though there's no number there, we kind of picture an imaginary 1 there. And so that means we have a positive, and so we are opening upward with a vertex of negative 7, 3, and an axis of symmetry of x is equal to negative 7. All right, the general form of quadratic function is f of x equals ax squared plus bx plus c. We've seen this already, where a and b and c are real numbers and a cannot equal 0. We talked about why it's important for a not to equal 0, right? Because if a does equal 0, we see that that x term kind of disappears and it's no longer a quadratic term. So we want to make sure that we claim that a does not equal 0. The vertex h comma k is located at, and this is a nice way for us to find that vertex from the general form. H will be equal to negative b over 2a, and then the k is the value is equal to when I plug in h into the function. So it's, in other words, f of negative b over 2a. Now this is coming from, these values actually come from the quadratic equation, because if you remember the quadratic equation, minus b plus or minus the square root, b squared minus 4ac divided by 2a. Notice that if we completely remove this piece right here, that inner side, we are left with that negative b over 2a, and that is what's forming our vertex here. Okay. All right, let's take a look at some examples. For the following functions, determine which way the parabola opens. Find the vertex and find the axis of symmetry. All right, so now we're looking at them in standard form. So let's take a look at this first one. Here, notice that f of x is ax squared plus bx plus c. So here we can see that our a is equal to 1, our b is equal to negative 10. So let's look for the vertex. Now since a is positive, this is opening upward, so it is going to be a happy face. But now let's find our x value of the vertex. Of our vertex is going to be equal to negative b over 2a. So negative b is going to be negative 10 over 2 times a, which is 1, and this gives us 5. Okay, so that tells me that the 5 is going to be the x value of that vertex form. So now I need to find, I need to be able to find the k value, and I'm going to do that by plugging it into the function. So we're going to do f of 5, and we're going to plug in that 5, so 5 squared minus 10 times 5 plus 24, and if we plug that into our handy dandy calculators, we will see that we get negative 1. So therefore our vertex is going to be 5 comma negative 1. Remember, this is our h value, this is our k value. Therefore our axis of symmetry is going to be equal to x is equal to 5. Okay. All right, try the next one. Pause the video. Try the next one on your own. All right, so did you obtain a downward in terms of direction? We got a vertex of -5 and 5, and then an axis of symmetry, sorry, as x equals -5. All right, let's take a look at the next example. Determine the equation of the parabola whose graph is given below. Note we cannot clearly identify the x-intercepts. So we do need to figure out what this equation could be. So we know that we have two different types of equations right now. Well, the first one that we have is we know that f of x is equal to ax minus h squared plus k, which is our standard form. And two, we have f of x equals ax squared plus bx plus c, which is our general form. And notice the standard form is also of times mentioned as the vertex. So what are some things that I can obtain from the graph? One thing that I see that is easily readable is this vertex, right? Notice that this vertex is given to us as, if this is -3, we have -2, so we know that we have -2, comma 3, -3. So we know that the vertex is given to us as -2, comma -3. Okay, so because I have the vertex, this tells me that my best choice to use would be A. So we're going to start with equation A. So we're going to have f of x is equal to a x minus, so now instead of h, we're going to go ahead and plug in -2 squared minus 3. So I plugged in my vertex there. Okay. So let's go ahead. So what does this tell us? So we're going to go ahead now that we have these values in, let's go ahead and plug in a point from the graph that I can identify. Okay, so we want to select a point. I'm going to go ahead and select the y-intercept. Now I'm going to pick the y-intercept because x is 0 and then I just have that y value. So it's a really nice point to be able to plug in. So let's go ahead and plug that in. So for that y-intercept, that f of x, that's going to be -1. And then I'm going to have 0 for that x value. This becomes +2 squared minus 3. And then I'm left with that a value. That's the value that I need to figure out. What is that value? So now here, we know that 0 plus 2, that's just going to give us 2. So we're going to go ahead and square that. So we end up with a times 4 minus 3 equals -1. Let's go ahead and add 3 to both sides. So we end up with a times 4, which is equal to, if I added 3 here, we'd end up with 2. That would be a +2. So now we want to go ahead and divide both sides by 4. And we see that we hit a is equal to 1/2. Now that we know that a equals 1/2, this means that the equation we have is y equals 1/2 x minus 2 squared minus 3, which can really be written as the function, right? So our f of x is equal to 1/2 x minus 2 squared minus 3. Okay. So now this is given to us again in that standard form or that vertex form. Same thing as our vertex form. Now, what if they said, okay, well, we want this actually in standard form. So let's figure out how do we write it in the second form. Okay, so the second form, we would take this equation here, f of x equals 1/2 x minus 2 squared minus 3, and we're going to go ahead and multiply this out. So because we are expanding this, it is really important that we realize that we are taking this binomial expression and we are multiplying it by itself. So it really becomes x minus 2 times x minus 2 minus 3. So when we multiply this out, we really should be foiling this out I still see quite a handful of students that forget to FOIL it out and they just square the individual terms. So this becomes 1/2, and then we get the expression here, x squared plus 4x plus 4 minus 3. So we're going to multiply out that 1/2, so we're going to get 1/2 x squared plus 2x plus 2 minus 3. So we're going to combine the minus 2 and the 3, so we get 1/2 x squared plus 2x minus 1. And so this right here, with our f of x, is our general form of the equation. Okay? All right. Let's look at the next example. So determine the equation of the parabola whose graph is given below, so we can clearly identify, in this case, we can clearly identify the intercepts. So let's go ahead and take note of everything we can gather from the graph here. So here we know that we have x equals 1 and x equals 4 as our x-intercept. We can see a y-intercept here of 0 and -8. We can also see, we can't clearly identify off the top that vertex there. So in this case, let's go ahead and use the general form. So the way we're going to use the general form in this case is we are going to use y equals a times x minus the x-intercept, x minus the x-intercept. And this is going to be the second x-intercept, so let's call this intercept 2 versus intercept 1. So here we know that y equals a x minus the first x-intercept. It's going to be x minus 1. X minus the second intercept is going to be x minus 4. So now what we want to do is, just like in the last one, we're going to go ahead and select a point to plug in. And because we have this y-intercept, I highly recommend that we use it, because that means that our x values are going to be 0. So when we plug in that y value there, can I delete this? There we go. That y value, we're going to get -8 for y, but here we're going to get 0 minus 1 and 0 minus 4. So this means that we have a times -1 times -4, and this equals -8. And so now we end up with 4a equals -8. And so therefore, I'm going to divide both sides by 4, and I get -1/2, oops, nope, -2, sorry, -2 equals a. So our a value is -2. So now let's go ahead, now that we know what our a value is, let's plug this back in, and so then we end up with 2 times x minus 1, x minus 4. But notice that because this is essentially in factored form, we want to be able to multiply everything out. So we're going to end up with -2. Let's go ahead and FOIL now. We're going to do x times x, x times -4, -1 times x, and -1 times 4. So we're going to end up with x squared minus 4x minus 1x plus 4. Combining those terms, we're going to get -2. And then we're going to get x squared minus 5x plus 4. And then we end up with -2x squared plus 10x minus 8. And so this right here is our expanded form of our function f of x. Okay, so the general expanded form. All right, hopefully you got that. All right, let's go ahead and end the video here. I'm going to create a separate video for the next section because we're going to be dealing with completing the square. So instead of making this video long, we'll just separate it out.